Hello everyone and welcome to Autodesk PowerMill. So we are going to start the module number 2, the 2D toolpaths and machining strategies. In this module we are going to cover the first face milling operation, then 2D curve area clearance, 2D curve profile, chamfer milling, hole making operations. So let's get started with the face milling operation. So here what you see over, the Autodesk PowerMill 2024 is loaded. And this is what we call the work area, where you can load the workpiece, you can load the model or anything. Or we can also say that this is a graphic view area. So for face milling operation, you just need to create a block. So just click on Home, and here you will see the block command. After clicking on the block command, you will have to define this by using a box. If you want a box, you want to click on the box command. If you have a picture, you can define it by picture. If you have a triangular model, you can define it by triangle model. If you have a boundary, we have to define it by boundary. Cylinder sector, spun pattern, and spun pattern sector. So I'm going to select box. The next option is coordinate system. So the active coordinate system is by default by the milling operation or by the power mill. Okay, so you will see the active work plane on a graphic view area. The next thing is you have to define the block limits in the X direction, total length, in Y direction, total length, and in Z direction, total length. So here we have three options: minimum, maximum, and the total length. So what I am going to do is I am going to define it. The length in X direction is 200 millimeters. The next is direction in Y, we have 200 millimeters, and direction in Z is 50 millimeters. So the power mill automatically defines that the maximum direction in X positive is 100 millimeters, and in negative direction, or we can say that X negative is 100 millimeters. So this shows that the block is created in the center of the work plane. But one thing you have noticed that the total length of the block is in Z direction is 50 millimeter. So this means that 25 millimeters material is placed on the upside and 25 millimeter is placed in the Z negative direction. So if I want to make the face plane of this block as a work coordinate system, so what I have to need is I want to shift the block in the downward direction. So for this purpose, I don't want to change the thickness of my workpiece. So I'm just click on the lock the total thickness of the Z, and I want to move 25 millimeter material in the Z negative direction. Or I can say that I just want no material in the Z positive. So I'll just write 0.0. So what the power mill is going to do is power mill automatically calculates that the total thickness is 50 millimeter, and the user don't need material in the Z positive direction. So 25 millimeter will be gone to Z negative. So just click on anywhere, it will automatically calculate the thickness. So as you see that in the Z direction, negative side, we have 50 millimeter material, and in Z positive we don't have any material. So our work plane is set it on the top face of this block. So this is how you can define the block. Let's click on the accept button to have this block viewed. So our work origin is at the center of this block. Now let's start how we can create a face mill operation using this block. As you see, or as you know, that Autodesk PowerMill is a CAM software. So you don't need to create any geometries or any models in this software. What you can do is you can import your designs from other softwares or any geometries from other softwares. If you need to create some boundaries or patterns, so Autodesk PowerMill gives you a little feature like boundary and pattern feature to create simple 2D geometries and curves. Okay, so here we have the line, circle, curves, text, and some editing tools like limits, join, segments, curve, transform, and projection to edit your curves. Okay, so in actually what I can say that you cannot create any 3D or 2D model in this software. Only just for editing you can create some patterns and geometry for only for your 3D models. Okay, so here I have a block, and what I'm going to do is I'm going to start a face mill operation. And for face mill operation you need a toolpath. So three things are very important for creating a face milling operation. First, you need a machine. So we need a 3-axis milling machine. So by default we have a 3-axis milling machine. We have a 3-axis coordinate. The second thing we need is the tool. So I need a face mill tool, or I need a required tool to face of this material. The third thing we need is the required cutting tool strategy. So for this purpose we need a toolpath. So you can access a toolpath by clicking on the toolpath and just create toolpath. Or we have multiple ways to access the toolpath. So just go to Explorer and find out the toolpath. Just right click and create toolpath. The next option is the toolpath, which I have set it already. The other option is go to Homes and you will find out the toolpaths. Just click on the toolpath and you will get a lot of options over here. You see the favorites, your favorite toolpaths, 3D area clearance, which we are going to study in coming video, coming lectures, and the curve machining. In this module, we are going to cover the curve machining operations or tool strategies. And this video, we are going to cover the face milling operation. So you see over here is the face milling operation. Just click on this and click OK. So here you will see the face milling operation dialog box is open, and you have the toolpath name. I am going to set it face mill, face milling operation. Okay. So the first option over here is the work plane. We don't need to create a work plane because it's automatically defined by the PowerMill. So we'll discuss all the work planes in the coming videos. Okay. So next thing is the block. We have already set it up the block. The next option is the tool. Yes, we need to create a tool for the face mill operation. So you have multiple tools over here. You have a list of multiple tools. First one is the end mill tool. The second is the ball nose tool. Then the bull nose. Then tapered spherical tool and tapered tip tool. Some drill tools, disc tools, and create an off-center tip radius tool, tap tools, and helical milling tools. We have lathe machine tools, grooving and probes, and some router tools over here. So you can create default tool. For example, what I have to say that I'm going to create an end mill and say that it's a face mill tool. So you have to define the name. I say that it's a face mill tool and its diameter is 20 millimeter. So I have defined its name to a 20 millimeter face mill tool, and I have to write the diameter of tool is 20 millimeter, and the length is automatically set it by default as 100 millimeter. So this is a tool number 1. I have to set it 1 number tool, and it has a flutes of in 4 numbers. So we have defined the cutting tool. The next thing is the machine tool. We have to define machine which we are using. If you have a certain machine or specified machine, you can set your machine file here and will get your machine's specification data over here. So we say that our machine is set it by default by the PowerMill, so we don't have any machine settings over here. We just leave this machine to settings and move towards the face mill operation. So this is the critical time to set the parameters for the face milling operations, and we will see that it says that the face definitions. So face Z position is 0, 0 right now by default. This shows that the cutting tool is placed at the Z0 level and which face Z level you want to remove. So this time it's Z0, and what I'm going to do is I want to remove Z minus 2 millimeter from the face. So I have to set minus 2.0, and it will definitely remove 2 millimeter from the face. A remaining material will be 48 millimeters from 50 millimeter. The next thing is the expansion. As you know that the face milling tool needs to cut all the way from the face, and it requires the expansion because we need to remove completely. We need to remove material from the face completely by the cutting tool, and this will be only happen if we extend our cutting tool path in X and Y direction. The expansion in X and Y direction is defined by this 0, 0 material. Okay. So this value is defined by the cutting tool diameters. So the diameter of the cutting tool is 20 millimeter, and if I said that I'm going to set it 10 millimeters, so it will extend my tool from the block. We can say that the 200 millimeter is the total length in X direction. It will make it 210 millimeters in X direction, and in Y direction is also 200 millimeter. So I just write it 10 millimeter. It will expand it to 210 millimeters. So engagement feed rate is 100 millimeters, or feed rate is millimeters per. What we have the pass rate is 100 millimeters, 100%. The next option is tolerance. The tool F-path accuracy you need is 0.1 millimeters. So you can set it 0.01 millimeter tool accuracy. And the style for the tool path is one way, two way, spiral, or one pass. So what I'm going to do is I'm going to show you how it just looks like. For example, I set it one way and the step over is 5 millimeter. I say that my cutting tool is 20 millimeter in diameter. So I'm going to set it that the cutting tool step over is 10 millimeters. And the cut direction distance in. So the stalk depth is 0, 0. I have to define the stalk depth, that the stalk is 50 millimeters. Okay. And the step down is 1 millimeter. As you know that we have set the face mill Z direction is -2 millimeter. We want to remove -2 millimeter from the face, and the depth of cut is, or we can say the step down is 1 millimeter. So it will take 2 steps to remove material from the face. Or if I said that 2 millimeter step down, so it will take 1 single step to remove the material from the face. Next option is the facing. We don't need finishing operation over here. And the raster, it will automatically define the raster direction in 0 degree, automatic verification. So we define all these settings by default. We just don't need any settings here. Go to feeds and speed and define the spindle RPM speed. So let's define that it's 2500 RPM of the spindles, and the cutting feed rate is 1500, and the plunge rate is 500, and skip feed is 3000. Set the coolant if you want. By default, I'm going to set it none. Click calculate to calculate your toolpath. So what you see over here is toolpath is generated above side of the workpiece. So this is done because we have set the face mill tool distance 50 millimeter in vertical. So just click refresh on it. Say that we just want to remove material. Stock depth is stock depth is 2.0. So what you see over here, it defines 2 millimeter stock, and it will cut in single direction. So let's simulate the face mill operations. Close this and so go to simulation option. Select the entity. We have the face milling operation, and the cutting tool is automatically selected. Click on play to get. So it goes over in alongside direction 10 millimeters, and the step direction is 10 millimeters. So what you see is it takes every single step to create face operation and go back to its initial position, take step. So this is what we can say that it's a single way operation. So this type of operation takes a lot of time. It takes cut and go back to its initial position for the next cut, and the step over amount is 10 millimeters. Or we can say that 50 millimeter is the step over distance. See, the overhead is along in X direction is 10 millimeters, and along in Y direction is also 10 millimeters. So let's change some options over here. Click on the face milling operation, right click, go to settings, refresh the setting, and set the style from 1-way to 2-way. Click on calculate, and you'll see that how it looks like. Go to simulations and play. So you see that it's working in zigzag direction. So let's change another option. We have go to settings, from 2-way to spiral, click OK, close, and let's see how it looks like. So this is what we can say the cutting tool pathway, how it cuts down the material. Let's go and change the other setting. There was spiral. We have one pass. Calculate. So I take a single pass to create face milling operation. If you have a diameter of more than 200 millimeters, then it will take a single pass to create. Let's refresh. Go on two-way. We can say that two-way step over is best related to this type of workpiece. Click calculate, OK, and close. So this is how we can perform the face milling operation using the Autodesk PowerMill. So I hope you understand the face milling operation, how we can set the cutting tool, how we can set the work plane setting and block setting, and how we apply the toolpath strategy, and the difference between one-way, two-way, spiral, and single pass. So, hope you enjoyed this video. This is what we get the results in the face milling operation. So, let's go to simulation. Click on this button, which is what we call the view mill, and it will actually remove the material from the face, and we'll see how it actually looks like on real-time machine. So you see that this 2 mm material is going to be removed from the face. So this is how the cutting tool operation is done. We have completed the face milling operations. Hope you enjoyed the video. So that's it. Thank you very much.